this chapter, we are talking about the different factors which are affecting the rate of reaction, out of which we did the first one, that is the first factor, that is a concentration. In the previous parts, we studied that the rate of reaction depends upon the concentration of reactant. The rate of reaction depends upon the concentration of reactant, that is the reactant is one of the factor which affect the rate of reaction. Now, the second factor which affect the rate of reaction is temperature. So the effect of temperature on rate of reaction. So effect of a temperature on the rate of reaction. Now if I'm talking about the temperature affect the rate of reaction. It depending on whether the reaction is, whether it will increase the reaction or decrease the reaction, totally depends upon whether the reaction is exothermic or endothermic. Generally, endothermic reactions are favorable at higher temperature and the exothermic reactions are favorable at lower temperature. So here we are talking about the with the endothermic reactions mainly. So effect of the temperature on the rate of reaction, I can say. So if the reaction is endothermic, as I said, then the rate of reaction goes on increasing with the increase in temperature. The question arises that why the rate of reaction increases on increasing a temperature. The simple answer, I can say, there are the two basic reasons that on increasing a temperature, the increase in a temperature due to the increase in a rate of reaction due to the increase in temperature. The number one, I will say more number of, due to the, once you increases the temperature, the energy of the reactant will increase, and if the energy of the reactant will increase, then simply I can say that more collision will takes place. So here, due to the increase in temperature, the more collision takes place. So more number of collision takes place once you increases the temperature. Then second, if I'm increasing a temperature, then the number of reactant molecule having activation energy number of molecules, reactant molecule having an activation energy also increases. For example, we did that graph. The graph was like this: energy versus reaction. This was the energy of the reactant. I said this is the average energy of the reactant. And for a reactant to get converted into product, they require this much amount of energy. So there were the certain reactant molecule whose energy was this much. Some reactant were having this much energy. Some are having this much. Some are having this much energy. So what happened when we increase the temperature? On increasing a temperature, suppose this reactant was having energy, like this is 60 kilojoule. Here we have 50, 40, 30, and this is 20. So this reactant molecule whose energy was 50, once I start increasing a temperature, that means I'm heating. So I'm supplying energy to this. So energy of this reactant molecule will increases from 50 and it will reaches to 60. And once it reaches to 60, will get converted into product. Means this reactant molecule whose energy was actually not equal to the 60 kilojoule, but due to the increase in temperature, its energy increases and it crosses this barrier. Simply on further heating, on further increasing a temperature, the molecules having the energy less than here, they also get converted into product. So I can say this is the main factor which increases the rate of reaction. That means when we start increasing a temperature by heating, means I'm supplying energy to the molecules, and once the energy is supplied to the molecule absorb those energy and get converted into their energy level increases, and hence they get converted into product. So the number of molecule having activation energy increases. Now we have, suppose if I'm having a equation like A is giving product, and if I'm writing its rate law, the rate law is going to be rate is equal to, let the reaction is the first order, K into molar concentration of A. Now, if I'm increasing a temperature, I said rate of reaction increases. Why rate of reaction increases? Now see, if I'm increasing a temperature, the concentration of the reactant will not increase. That is, the concentration of reactant will remain constant. But still rate is increasing. That means on increasing a temperature, what factor increases? K. K is a constant, that is a rate constant, which only and only depends on temperature. Once you increases the temperature, the K will increase. Once you decreases the temperature, K will decrease. So temperature increase, K value increases, so that the rate of reaction also increases. How much rate of reaction will increase? It totally depends upon that how much K value has increased. Now we have a term called as a temperature coefficient. That temperature coefficient tells us that how much time the rate constant increases, or how much time the rate of reaction will increase. The formula we have, temperature coefficient, let I am representing it by N. Here the N stands for temperature coefficient, not the order of reaction. So temperature coefficient, the formula is rate constant at T plus 10 Kelvin. Suppose I am having a temperature whose temperature was, suppose I am having a reaction whose temperature was T Kelvin. Initially the temperature was T Kelvin for a reaction. And then I increases this temperature by 10 degrees Celsius, or 10 Kelvin temperature is increased. So suppose if it was 50 Kelvin temperature, now I had increases the temperature to 60 Kelvin. If it was 80, then I increases to 90 Kelvin. Means the temperature has been increases by 10 Kelvin. If you are increasing a temperature, then ultimately the rate constant will also increase. So for calculating a temperature coefficient, we are taking a help of rate constant. So it is a ratio of the rate constant at T plus 10 Kelvin, that is at higher temperature. The temperature increase means K value will also increase upon the rate constant at T Kelvin. So here we are writing the temperature coefficient for the increase in 10 Kelvin temperature, and it has been observed that if you are increasing a temperature by 10 Kelvin, the rate constant value increases by a factor of 2 to 3 times, means it generally becomes 2 to 3 times. So here the value of N is going to be a greater than 2 and less than 3. Means on increasing a temperature, the rate of reaction increases by a factor of 2 to 3 times, because the rate constant increases by 2 to 3 times. For example, at this temperature, suppose the rate constant value was 5, the K value. So there is a possibility that if you are increasing a temperature by 10 degrees Celsius, the rate constant value will become 10. And if rate constant value become 10, then the temperature coefficient is going to be 10 upon 5. That is, answer is going to be 2. So this is a temperature coefficient. The value of temperature coefficient tells us that how much time the rate of reaction has been increased if on increasing a temperature. Now it's a generalization. Generally we consider that if I'm increasing a temperature by 10 degrees Celsius, then rate of reaction becomes double. It's a general statement. That means, so again in MCQs, the question is asked on this temperature coefficient also. Which type of question is asked? Let's see. The question is like, how much time the rate of reaction will increase if the temperature of a reaction increases from 40 degrees Celsius to 80 degrees Celsius. 40 degrees Celsius to 80 degrees Celsius. Means the temperature is increases by 40 degrees Celsius here. Or instead of 40, suppose it's a 90 degrees Celsius. So how much time rate of reaction will increase? Well, simply I will say 40 degrees Celsius. At that time the rate of reaction was X. When it becomes 50 degrees Celsius, the increases the temperature by 10 degrees Celsius. So it will become double the rate of reaction 2x. Again I increases the temperature by 10 degrees Celsius, becomes 60. 10 degrees Celsius from 50, not from 40. So 50 to 60, 10 degrees. So the rate of reaction will double. Means from 2x it will become 4x. Then I increases the temperature to 70 degrees Celsius. Again 10 degrees Celsius, so rate constant value will doubles. Then from 70 I increases to 80 degrees Celsius. Again it will become 16x, and 80 to 90 it will become 32x. Means ultimately I can say that if you are increasing a temperature from 42 degree 90 means what was the question? If on increasing a temperature, if the rate of reaction doubles on increasing a temperature by 10 degrees Celsius, then how much time the rate of reaction will increase if the temperature changes or increases from 40 to 90? So I will say if you are increasing a temperature from 40 to 90, then rate of reaction will be changes by a factor of 32 times. Means the rate of reaction increases by 32 times. So this is the effect of temperature on the rate of reaction.